Thank you everyone for joining the July Brown Bag webinar. I'm really excited to introduce our two panelists today. First off, we have Grant Ivison-Lane. He's the founder and managing principal at Terranewt, an advisory and consulting service company for nature-based products and programs. Grant's background is in corporate greenhouse gas accounting and ecosystem services assessment. At SIBO Technologies, Grant led the development of one of the first products to use process-based modeling for inventory and intervention greenhouse gas accounting. Grant has been engaged with standards development as a member of the GHGP land sector and removal guidance and the actions and market instrument working groups. He is also a part-time faculty member at Colorado State University, where he teaches Scope 3 greenhouse gas accounting. Thanks for joining us, Grant. Next up, we have our own Mariana Ortega Ramirez, who is a senior analyst joining EarthShift Global after building a thriving sustainability consulting practice, specializing in agriculture, forestry, livestock, and fishing, with special attention to the mapping of stakeholder perspectives. She works on life cycle studies for clients in agriculture, textile, industrial process, and energy sectors. Her experience in material flow accounting, handprint assessment, SROI, and LCA for policy programs such as 45Q is continuously increasing with practice. Her educational background in engineering and industrial ecology, plus her experience collaborating with a myriad of sectors in various arenas, has developed into the ability to grasp technical aspects in production processes and also the larger picture. Thank you, Mariana. Before I pass it off to our panelists, I just want to let everyone know that you can put any questions you have about the presentation into the Q&A section. At the end of the presentation, we're going to take some time to go through and answer all of those questions. So without any further ado, take it away.
Thank you, Noel. So I'll be providing a quick starting context on this talk. We first collaborated with Grant. Can we go to the next one, Grant? Factoring in data from assessing the carbon footprint of an agricultural product, and specifically about taking into account the carbon in soils, and and specific to a client project. And so I want to start by saying in LCAs, we don't only look at the climate change impact category, but at a collection of indicator results for a comprehensive set of impact categories. That's kind of the difference between an LCA and a carbon footprint study. Maybe we can go to the next one. What is an example of the impact categories that we look in LCA? We have climate change always. It's one category that our clients are very interested in always, and yeah, as you know. But we tend to say to our clients, it's important not to have only the carbon tunnel vision and look at other impact categories. So an example in the ES Plus method that EarthShift developed, we have climate change, water scarcity, resources availability, ecosystems, human health, cumulative energy demand, and depending on the type of project, we also include others that are important to also look at, for example, land use. We can go to the next one. A carbon footprint focuses only on looking at the climate change impact category. It does not match, let's say, the comprehensiveness principle of the LCA, but still provides a lot of information. For example, when following ISO 14067, we know that we have to report that impact category, showing specifically what's the impact, what the results for the net fossil greenhouse gases, the biogenic part, the direct land use impact, and so on. So it still gives us a lot of information, and it goes some more layers in depth when working with ISO 14067, but there are other standards also focusing on carbon footprints. And yeah, if we go to the next one, some examples of why we recommend to look at the whole LCA profile is because these graphs show two examples of projects that we have been working on, and it allows us to see, yes, maybe a company is deciding to have a specific carbon management plan at the farm and reduce the global warming impacts for their product. But we have to look, or we recommend looking at the other categories as well, because there might be trade-offs. And in some cases, you reduce the carbon, as we see on the graph in blue, but all the other categories go up in impact. This doesn't happen in all cases, as you can see in the other graph. But yeah, we recommend looking at all. Today, we'll be looking specifically at the carbon impacts, but the context is that this is part of a story that can be considering more. So if we go to the next slide, I want to pass the floor to Grant by asking if agricultural inputs are the hotspot in your supply chain. If we imagine that, how can we reduce the environmental impact of the product? Well, we would have to make changes, right, into how that product in the landscape is being produced, and so we want to measure that change, and that includes measuring the increase or decrease in soil carbon stocks. And for that, we cannot rely only on generic LCA datasets that we commonly use when screening or scoping the impact of our product. And so Grant specializes in getting that primary data to be able to see that change between the baseline and the good or the change we are making when specific programs are put in place for agricultural supply chains. So yeah.
Great. Okay. So I will just preface this, and I think it's really important, and thank you, Mariana. I think it's really important to look systematically when we approach the natural environment in general, right? Because if we try to change one thing in nature, everything's interconnected, right? So we're going to change lots of different things. And I'm a greenhouse gas accountant, so I've always, focused on carbon, but I also understand that particularly in these systems, you can't ignore the co-benefits. And I think it's really important up front to just call that out. So what we'll do, over the next 10 minutes or so is I'll go really into the weeds with y'all, probably more than you would want to, on soil organic carbon and how it's reported towards standards. I know the title of this webinar was, quite a mouthful, but I do this for a living, and it's kind of funny that this is just, an 8-hour-a-day job for me, but you'll see why it's relevant. It's something that a lot of companies are focused on. And then towards the end, we'll kind of blow this out a little further and revisit that conversation around co-benefits, because I think it really is important. And I'll try to sprinkle in a lot of that as we go through this. So to kind of set the stage here, you're looking at a couple of busy figures, but I think they're really important to just ground ourselves in. So, we have managed agricultural land on planet Earth for thousands of years. Through this management, we have become more industrial over time, and there are impacts. There are natural impacts to the land from the way that we've managed them in an agricultural context. One of these impacts is we have lost soil organic carbon at a large scale. It's not uniform, and you can see that through the figure on the right here. It's not uniform throughout the planet. Some areas have lost more than others, but it is, it is something that we're grappling with. So this results in a release of carbon to the atmosphere. That's why it's relevant for climate change. But this is also relevant for things like food security, the long-term production of agricultural land. We need a healthy soil organic carbon stock to ensure that a healthy, stable soil organic carbon stock to ensure that land's productive for a long time. I'm based in the United States, so I threw in a figure here on the left of Illinois just so you can get an idea of the magnitude of change that we're seeing, that we've seen over the last, 150, 175 years. And you can see it is significant, right? So there has been quite a bit of loss in certain geographies. And so that's the bad news. The good news is we can change this. We can reverse some of the negative impacts. And we can do that, and that helps us, improve the overall carbon budget of agriculture. It also helps us, improve the long-term sustainability and productivity of agricultural land. And how do we do this? We do this, primarily through practice changes. So, managing agricultural land in a different context. It's not going to be the same everywhere because there's different needs in different geographies. And the impact of adopting what are conservation practices, or what's often referred to as regenerative practices in the sustainability space, the impact of that is not uniform. And so there's a study here that came out in Nature last year that shows what to expect as far as impact if we begin making this transition on agricultural land. So the good news is we can take some of that carbon that we've emitted to the atmosphere from agricultural land and put it back into the soil if we manage it and in a thoughtful way. Now, in the same context, companies have aggressively set greenhouse gas targets. I think something like a third of the global market capitalization, maybe approaching like a half now, has set targets with the Science-Based Target Initiative. A lot of companies that have set targets are, companies that source from agricultural land, and most of their carbon footprint, if you dive into it, is on farms. So those companies are really eager to figure out how they can, balance their carbon budget and achieve their targets. So they really want to measure this change, and that's where things get more complicated. And Mariana mentioned we've worked together on this before, and so this is really what I focus on with companies. So just up front, it is uncertain. The impacts are not uniform. They vary by geography and over time, and sequestration may not be happening everywhere, right? But that might be okay, because even if we're not storing carbon every year, we can limit fluxes to the atmosphere as much as possible, and that's better than a business as usual scenario. So let's go into the weeds a little bit here. How do we approach this, right? Like, where do we start? I think a good place to start, if we're thinking about integrating soil organic carbon and complex measures of it into a life cycle assessment, just the greenhouse gas portion, right, is what are our goals, right? Like, what are we trying to understand from this exercise? And I think, there can be, that can really help us figure out exactly what we need to do as far as a scope of work for that, right? Maybe we're just trying to compare different geographies. If we are, and maybe not report to standards, there's a little bit more flexibility in our approach. Maybe we're just trying to make a product-related claim, and we're not really trying to go into the weeds on the standards-aligned reporting side. But if we are, really hoping to report towards a standards-aligned greenhouse gas target, supported by Greenhouse Gas Protocol or the Science-Based Target Initiative, or ISO, right? ISO is going to have different requirements than GHGP, but they have just announced a partnership and are hoping to kind of align their standards, so that should be good for all of us as practitioners. If we're trying, to make that standards-aligned claim, well, now we got to go into the standards requirements. And so that's what I'm going to share a little bit with y'all today, just to give you a flavor for what that means, because that's what I spent a lot of my time focusing on. So Greenhouse Gas Protocol put out the land sector removal standard this year. This is the first standard from GHGP to address sequestration. So that's a big deal if we're focused on soil organic carbon. Just to get started, they set clear boundary requirements on where we can make these kind of claims. So if we want to claim soil organic carbon towards, within an emission factor from an LCA towards a target, we need to be mindful of the boundary we're setting. And so what that means is we need to be at this sourcing region level or below. We need to have an idea of where the commodities we source come from. And we need to be able to kind of bound that in what's defined as a sourcing region here. And we'll go more into the weeds on greenhouse gas requirements, or the standards reporting requirements towards the last couple slides, but just giving you an idea of how, understanding this up front with our goals can really help us understand exactly what's going to be needed with an approach. So let's say we have a good idea of where we're operating. Now we want to go, we have all of these fields that are producing commodities. Maybe we have a project, right? And we want to measure soil organic carbon change. To measure change, you need 2 points of time, right? And so here's a field that I drew, and you can tell I am not an artist, but standard agricultural field. There's different colors here and different shapes on this field, and these are, strata, so it's different soil types throughout the field, and each soil type has different characteristics. Maybe the soil texture is different, the density is different, the soil organic carbon content, the soil organic matter in that field is different. And what we see when we look at even a given field, even a given subsection of a field, is there's a lot of variation. And why is this variation there? This is due to natural factors and how the soil's formed. It may be due to management factors and how they've been managed over time. And so there's a lot of variation to kind of grapple with, even at a single field scale, and trying to come up with a measure of how much carbon is in the soil. In addition to that, it can take a long time to detect significant change, right? So each year, that soil organic carbon pool changes, but you saw in the figure for the first slide that I showed, the change that we saw in Illinois, that was over 150 years. Companies report their greenhouse gas inventories every single year. So the time boundary is a little funky here. And so, a year is not a lot of time in a geologic, soil context. And so, ultimately, it can be really hard to measure change because it's so small in relation to this very large soil organic carbon pool. And so that also, introduces some uncertainty. To make things more complicated, and we're going to make them more complicated before they get more simple, so we're just going to keep doing this trend here. Every year, the change is not uniform, right? So, how much my soil organic carbon pool changes on this field is going to depend on how it was managed that year, and it's also going to depend on the weather, right? So what did I grow? How much biomass went on the soil? How much of that biomass did I remove? And how much residue is remaining? How did I till the soil? How much precipitation was there? What was the temperature like? All of these factors play in and influence how much the soil organic carbon pool is changing in a given year. And so that's more variation to grapple with. In addition to that, when we go in and measure, there's also going to be measurement error. I have worked in a soils lab before. If I am measuring your field, there's definitely going to be error because I'm not good at it. So, this is just something that we have to grapple with, is the measurement process itself is also going to add some uncertainty into this system. So where does that leave us? That leaves us with the takeaway that, reporting soil organic carbon change often has significant uncertainty, and we need to be able to manage that uncertainty. And, there are, different approaches to reduce uncertainty as much as possible. One is scale. So if we have a lot of scale, typically what we see with these approaches is we can reduce uncertainty. And if we have more time, we can reduce uncertainty, and it's easier to kind of measure and track those signals, right? But there are also challenges as we scale approaches, and often these investigations into how much soil organic carbon is changing are going to be over larger landscapes, and on these large landscapes, the most straightforward thing to do would be like, well, let's just go measure, but measurement can be really expensive and not cost effective for a project. So that means that we might want to explore other approaches. The simplest approach to estimating soil organic carbon change would be to use factors from the IPCC. These exist, but these are really high-level estimates of what's changing, and they're not really tailored to exactly to how a project is being managed. So ultimately, where that's landed with the standards is these are not allowed for claiming sequestration towards greenhouse gas targets. And so we have to figure out how to get more into the details here and be as accurate as we can within our budgets. And so ultimately what that means is, we could look at soil sampling, but like I mentioned, it's expensive. We might look at using process-based modeling. This is scalable. There's added benefits to using models and that we can run different scenarios once we've created this kind of digital twin of this agricultural system. There are really interesting emerging technologies over the past like 5 or 10 years, such as digital soil mapping. So this is where we maybe take some soil samples and then use satellite imagery, machine learning, drone technology to try and create a complete map of the soil system. And then there's also in-field spectroscopy, which is really interesting. And so there's companies that are emerging, kind of trying to reduce, the costs through these kind of technological advancements. And ultimately, what you might see on a project is a combination of these approaches. Maybe I'm using soil sampling and process-based modeling in addition to digital soil mapping to try and find the best solution for the crop, the geography, and the practice and the goals of the project. One challenge associated with this to be mindful of is, some of these approaches take a lot of data. Using a process-based model, that's going to take a lot of data. We can, we can often go and collect a representative amount of data, but we need to be mindful of data entry errors, right? Because we're all human and we make mistakes. So we need to be able to correct those errors. If we're using, more kind of cutting edge remote sensing solutions, it can be really hard to identify a source of truth. And so I think we have to have some kind of idea of how accurate is this solution all of the time, right? So maybe it's accurate in one year, but not the next because there was a lot of cloud cover or something. We need to be able to understand and characterize that. And then in addition to that, how representative is the data I'm using for a given geography, right? If I'm looking in the middle of a state in the United States, but I'm using the state level average for yield or something like that, that's a representativeness challenge that's going to add more uncertainty into my approach. And so I included here a bunch of different metrics that can, create challenges as we kind of build these systems to measure carbon stock change over time. But it can be a challenge to kind of grapple just with the data going into the model in addition to the uncertainty coming out. Once we've gone through that effort though, and people do, lots of people do, we get to the point where we're ready to report our change in soil organic carbon. If it's an emission, we'll report it as an emission. If it's a removal, we'll report it as a removal. But once that's kind of integrated into our LCA, if we want to report it towards these standards, we need to be aware of the high level requirements for reporting and alignment. So these are, the greenhouse gas protocols, land sector removal standard requirements that just came out. This is more high level, right? So at a high level, we need to make sure we're using attributional greenhouse gas accounting. That shouldn't be too surprising. So just making sure there's no counterfactual scenario considered as we're reporting the greenhouse gas impact. We need to have that sourcing region level of traceability. So what that means is we need to have an idea of a pretty good idea of where the commodity is coming from. Companies need to use consistent allocation boundaries. So what that means is you can see here on the right, there's lots of different subcategories. So we need to make sure that our carbon intensity value, we're reporting emissions separate from removals. So that's a requirement. We're not netting everything together. And then for the emissions category, we're reporting different emission sources in the corresponding category. So we're reporting land use change emissions separate than land management production emissions, which would be like N2O or CH4 emissions on the field. And then we're reporting the sequestration separate under removals. And as how we're allocating emissions, from the field to the corresponding agricultural product needs to be consistent between emissions and removals. So that's another requirement here. And the removals are accounted for using a carbon stock change approach. So that's just looking at the carbon stock in time 0 and seeing the change to time 1 or time 2 or time 3. Related to the sequestration component of this, because that's the focus of this talk, is overall, this is not a requirement if you're reporting towards standards to report sequestration, so it's optional. Companies don't have to do this to be in alignment with the standards, but usually they want to because it's a positive impact and they might be able to get some credit towards a target if they can report it. If they do, there's additional safeguards just for removals. I mentioned the traceability component of this. There's some flexibility here with reporting traceability. This is a big challenge for companies because they're not necessarily able to trace a commodity all the way back to the farm. So there's an interim traceability guidance that Greenhouse Gas Protocol put out. If you can't, trace your project all the way through the supply chain, you can report with what's called impact traceability separate from the inventory. This is an ongoing area of effort. It's all in service of trying to avoid double counting, which is just an ongoing challenge in the space. So it's definitely not figured out, but you can see it's stressed pretty heavily in the standard to do the best we can. When we're reporting those removals, as we kind of looked through at the high level framework, we want to make sure we're using data that's specific to the carbon pools that we're evaluating. We're using what are called IPCC Tier 3 approaches, so that'd be like soil sampling or detailed modeling, and we need to be able to report uncertainty associated with our estimates. Once we report that sequestration, we need to be able to monitor it over time because it's impermanent, right? It's in this living pool, so we need to be able to track it and see if it is reversed, and then those companies have to report that as a reversal. What I've shared so far on these standards, this is not exhaustive. It's a pretty big document, but I just tried to hit the high points. So definitely, if you're curious about this space, would recommend going and reading the Land Sector Removal Standard and the guidance that just came out a couple of weeks ago that goes much more into the details on each of the requirements. I think this is the best standard that Greenhouse Gas Protocol has written, and it's definitely worth taking a look at. So that is as in the weeds as we could have gone, probably in the time that we have on SOC and reporting it towards corporate targets, integrating it into LCAs. Now, there is a bigger picture here. And I think we need to be really mindful that optimizing for carbon, like Mariana was showing in her figure, does not necessarily get us where we want to be with regards to maximizing the total social benefit of managed land. And so, ultimately, there's a lot of focus from the corporate reporting side on carbon. And, that's great, but we need to be more systematic with this approach. And now we're seeing more and more frameworks coming out that capture all of the other benefits that are on the left of this figure that are more focused on things like water, land, biodiversity. So this would be like SBTN, the Task Force for Nature-Related Financial Disclosures. So we're seeing more and more, momentum into taking this systematic approach. But in the meantime, where that leaves us is if we're making a greenhouse gas related decision, we really need to be mindful of this stuff. And I think that that's where an LCA can be very helpful and powerful. One example that I bring up a lot is irrigation. So I could reduce carbon intensity by irrigating certain geographies that for customers that I work with. I could say, hey, just irrigate and we'll reduce carbon intensity a lot. But if it's in a water stressed area, we probably don't want to do that, right? And there's a reason it's not irrigated right now. And so that's just an example of how the carbon tunnel vision can really limit what we, the solutions that we come up with. In addition to that, I think as we look more towards the total comprehensive social benefit of these actions, we can close the financial need for farmers, because once we realize how much benefit could occur from these changes, well, then we could justify more investment. And I think that's another really important factor here. So in conclusion, there's a large greenhouse gas benefit to considering soil organic carbon in the GHG budget of agriculture. As you've seen, measurement can get pretty complex. The way that we approach that measurement really is going to depend on the goals of the LCA. And if we want to report towards corporate greenhouse gas standards, we want to make sure that we're, addressing the complexity associated with that, gave you a flavor for that. And overall, we want to be careful not to just optimize for this single metric, as important as it is. We really need to balance trade-offs. So that's all I had. So we could move over to questions.
All right, thank you both so much. We have a couple questions rolling in, and we'll start with a question around the scoping of these regions. So one question is the state level an acceptable sourcing region level, county level, or does it have to be a smaller scale? So essentially, what are the parameters in which you look at these particular regions?
Yeah. So the land search and removal standard goes into pretty good detail on how they define a sourcing region. So ultimately what's leveraged, this is for probably the first time in their standards, is they leverage chain of custody models. And so I think a group level mass balance is what's required to establish a sourcing region boundary. So that if you can establish that group level mass balance chain of custody, then that might be at a state level. But that's kind of how that's where they draw the line here. One thing I'll say is that there is an ongoing effort within the greenhouse gas protocol to make this more flexible, because even that group level mass balance can be really challenging to establish, really challenging for a lot of companies. That's why the guidance is interim. And so through this new actions and market instruments working group that's been going, actually it's been going on for like over a year now, a new standard will be released. And I think that that's going to that's definitely going to overhaul this traceability system and hopefully make it more workable for companies.
Thank you. We have a couple questions actually on using these results and interpreting these results in comparison to other studies. So our first question here is about how do you practically integrate removals inside an LCA? LCA tends to be a static calculation, while removals are yearly accounted for.
Yeah. Mariana, did you want to?
Yeah, sure. So first you have to have the data, of course. And then we want to, I think I remember the standard considers that if you, at least you have to consider one crop cycle. Of course, that is too little, as Grant was saying, the amount of carbon that you're going to be able to see there, maybe it's going to be little. So I would say it's not short-term thing. But accounting it in the model for LCA is quite easy. You just have to have the data and put it into the model as biogenic carbon that is stored in soil with the right characterization factor.
Yeah.
So the reporting of that then depends on the framework that you are using, what you are required, how you are required to report it. I would say that the modeling for a footprint or for a carbon footprint or an LCA, the effort is basically the same. It's just the reporting to meet the greenhouse gas protocol or the ISO that takes a bit more, or other standards, right? Depending on the different categories where you have to document with clarity, transparency, each number.
Yeah, and I'll just add, and I didn't necessarily address this question in detail here. This is one of those things where it's not exhaustive. If we have a project level LCA, so there's a geography where we're evaluating how much the carbon stock has changed over time. This is addressed in the standard. So what they've offered is you can look at the carbon stock change over the full rotation. So you could look over multiple years, but then what the corporate needs to do is allocate that back through the individual years. So kind of like partition the removal for each year that they're reporting, and that's kind of captured in the allocation requirement section of the LSRS, and there could definitely be more there, but it is I think an important challenge, which is the time boundary of this can be kind of funky for companies because they're reporting on this kind of like annual basis, but some of these impacts happen over longer periods of time. And I think, related to this static calculation of an LCA, what this ultimately tells us is that static estimate is probably not representative over a decade, right? Even over a given year. Like this is a very dynamic system. And so, I think that that's a larger discussion of like, how do we accurately represent this very dynamic system with these very kind of static, measurements over time? And it's a really important question.
Well, I'll go ahead to the next question, which your previous answer may have answered a little bit already. But one attendee asks if comparing results that account for soil organic carbon flux to results that don't, is there a best practice to estimate the potential real impacts of the other result without the soil organic carbon flux accounted for? Or is it best not to make comparisons at all? As you say, these studies are on a smaller time scale.
Yeah. And, I'll say, like, as a practitioner, in past jobs, I've addressed this question a lot where, my team came up with a way to estimate the carbon footprint of a commodity. And then we deliver that to a customer and they'd be like, well, why is that different than EcoInvent? And I'd be like, because EcoInvent's its whole other methodology. And so the challenge with this is we don't necessarily have methodological consistency when we're coming up with like the carbon intensity of a commodity. Even if we had methodological consistency. So let's say we got the emission sources to match. We may have different primary data feeding into those emission sources. So like I have really good data in the United States, but if I'm comparing that, to a geography where I don't have really good data, well then I think comparability, becomes more of a challenge. There's more uncertainty in that approach. In addition to that, even if I'm just within the United States, in a given state, there's so much variation, and that's not because of the way people farm. That's just because of the way the natural environment responds, right? And so like it's really challenging to make comparisons between geographies with agricultural carbon intensity. Especially if we go in saying, well, I want the lowest number and every geography should be able to be as low as this geography because there's just like real natural system limitations to what we can do. And that doesn't mean we shouldn't source from these geographies or shouldn't farm these geographies, but we need to contextualize them,
Thank you. More questions rolling in. How can biochar fit into the SOC reductions?
Yes. I don't work with biochar very regularly, but I'm an admirer. So I think that my understanding is if you're applying biochar on a field and you can measure that change over time and it's within the supply chain and meets all of these requirements in the land sector removal standard, you can claim that as a removal towards a greenhouse gas target. So just have to meet the requirements here and measuring, reporting uncertainty, making sure that we're traceable to a supply chain, et cetera.
Thank you. Next up, someone asks, how can the land use change indicator be converted into an actionable flag metric for operational decision making? And what methodologies and data are needed to ensure alignment with SBTi accounting requirements?
Really good question. And Mariana, let me know. I don't mean to capitalize on all of these either. So if you,
okay. You are the star in this webinar.
I don't know about that, but so SBTi sits on top of greenhouse gas protocol standards. That's what they point to. So if you want to, they may add some more flavor in addition to the foundation that GHGP has, but we can refer to GHGP to get started. There's a land use change chapter of the land sector removal standard, and you may have already seen that, but it goes into the different approaches that corporates can use to quantify land use change. There is pressure in the standard to use a direct land use change approach. Personally, that you could also use statistical land use change or jurisdictional land use change. I'm more of a fan of jurisdictional land use change personally because I feel like it really helps measure, the overall pressure in a given geography. And if we're just traceable to the lands that we source from and only report direct land use change, we may have like kind of these islands of excellence in the middle of deforestation. And so I think I'd always recommend using jurisdictional land use change actually, because I think that that's a better mechanism to track change over time and to hopefully incentivize investment to kind of prevent deforestation. But any of those would align with a flag target because they're all approved through GHGP. There's certain requirements in that land use change chapter to go and look at, like you have to use the same approach for every sourcing region, et cetera. I think it's every sourcing region and volume of commodity, but definitely worth taking a look at if you want to get more into the weeds.
Thanks. We have next up, a viewer says, thank you for all the info. Are you aware if there has been any effort to provide guidance in translating the methodologies of carbon credit registries with LSRG guidance and SBTi? Often carbon credits will include removals, reductions, and leakages, so there may be confusion in the market that these headline values may need to be split into different greenhouse gas accounting categories.
Yes, that's a really good question. So one thing that, just going back to my reporting table here, so one thing that is required for companies now that have biofuel related emissions is they have to evaluate land carbon leakage, which is effectively indirect land use change. This isn't reported within the inventory. It's kind of reported alongside the inventory. That's why it's called like an additional accounting category. So that's one, one change here that came out with the land sector removal standard this year. There are also requirements in here related to actions where there are quality criteria that are proposed for claiming credits within the supply chain. Because this is always an ongoing conversation. If you're a company, if I know I source from agriculture and that I know I source from this geography and this carbon credit program has a program operating in this geography, why don't I just buy their credits? Because it's the same stuff that I would be doing, but it's way easier for me to just support their program. So I think that there is more conversation around the right way to approach this kind of reporting. And that's where, we just saw a new standard from SBTi, the Corporate Net Zero Standard V2, which, begins to look more at these EAC style certificates, how a company reports them, how they get credit towards a target. It's more of an ongoing discussion there. And then this action of market instruments standard from Greenhouse Gas Protocol. You can see the white paper on the GHGP website now, but ultimately what we're landing on is we'll have the physical inventory, but we'll probably also have a market-based inventory where we can report certificates that have a carbon intensity, and then, an impact-based statement where we would report carbon credit outcomes either within our value chain or outside of them. So trying to create the right places to report the right kind of greenhouse gas metrics from the action we're taking as companies. So we're seeing Greenhouse Gas Protocol and SBTi, I think, try to figure out the right way to approach this.
Well, I'll skip ahead a little bit because we have another question related to that. Of those interventions, or of the intervention you study, what have increased the soil carbon the most?
So going to depend on the geography, and the amount of time that we're looking at, what commodities were grown. I think there's a lot of variation. So like that slide I showed from Basso et al. 2025, you can see there's a lot of variation just within this single geography. And I think these are looking at pretty consistent practices. What you hear a lot is cover cropping, reducing tillage, but there are other practices that are really important. Crop rotation is one that's talked about a lot. There's interesting like inputs, like biological inputs, intercropping. So there's lots of conservation practices that I think impact the soil organic carbon pool, and the impact is not uniform, and it's based on a bunch of different factors. So I'd say like it's definitely regional, and another factor to consider is like what's possible in a given geography, and where's the infrastructure to support farmers to learn how to do this stuff, and if it makes sense to it's got to make sense to their bottom line.
Thanks. Our next question asks, what are your thoughts on reporting annual 1 year of removal of CO2 equivalents, where the IPCC framing considers the warming impacts over 100 years? In other words, how to equate the 100-year impact of emissions from diesel with 1 year of storing carbon in soil?
Yeah, great question. So this came up a lot during the technical working group for when developing the land sector removal standard. And it's a really important question, right? Should I just be netting out fossil fuel emissions with this impermanent carbon that's in the soil that I could easily be reversed just by the weather? Probably not, right? Probably not a good idea to do that. Those are not equivalent. And so like this concept of fungibility, I think is really important. And I think that's ultimately why Greenhouse Gas Protocol has created this separate category for reporting removals and why we need to monitor that soil organic carbon pool over time. If we monitored it for 100 years, then sure, maybe, but that time boundary is really important. And I think that this is, what SBTi is grappling with too, and trying to say, okay, what does it mean to be net zero and how do you factor in sequestration towards a target? There's a proposed approach in the first flag standard that SBTi came out with. And ultimately, I think what it's going to look like is probably taking all of the agricultural emission sources and tracking them separate from the energy and industry emission sources like fossil fuel. And not necessarily like netting these things all together into one number. I'm very anti-netting. I don't think it really helps us to reduce everything down into one number, although a lot of people want to do it. I think we're fully capable of looking at lots of impact categories and deciding if a company is doing enough to be recognized. So
One number is so much easier to read.
Oh yeah, it looks cool, but yeah. Mariana?
If I may add, I think in the end it becomes a methodological choice, depending on the standard you're using, right? The calculation that you're gonna follow, how you usually to see a change in soil carbon, the IPCC says you take 20 years. ISO says 10 years, and at least you have to look at 1 year. And one analyst may say, well, that doesn't make any sense because exactly what you said, no, it's 100 years. The characterization factors are built for 100 years. Usually we use that 100-year characterization factor. And whatever the methodology, whatever the number, it's important for making comparisons, for reporting and all, but I want to bring the idea that what is most important in reality is making change happen. And sometimes, I don't know, Grant, if you have also seen this, but what I have seen is that there are companies doing a lot of good in landscapes and they are not measuring the carbon. But you can visibly see the change in the landscape, like grasses that grow bigger. You see more biomass with each cycle there, and they are not measuring, but it is there. So I would say that this question is important. The methodology we use is important in discussing how the model is built and is more aligned to what in reality is happening, choosing that and trying to be very transparent and good at calculating. But the most important thing is that it is something is happening in the territory and that the tools and the reporting, all of it that we are doing, go back to the origin of that, making that change happen.
Totally. Yeah, I think that where we've landed just as practitioners is our greenhouse gas accounting is often an impediment to change. It's like this barrier to entry to be able to take action. And I really don't think I don't think what I do is that important personally. So, if someone wants to go and do something and they know it's beneficial, at least for inventory accounting, the whole reason we created the greenhouse gas inventory was to identify hotspots and to take action. I think, you could argue for LCA, right? You're looking across multiple impact categories, identifying hotspots, taking action. Where we've landed in this agricultural context is we actually have a lot of evidence where the hotspots are, just from academic literature, from public investment. So we already know, in a lot of contexts, like what we need to be doing, but I've seen a lot of limitations to action because there's not a greenhouse gas reporting scenario or system to make it make sense, right? I think, like the question here of, okay, like this can get pretty messy with LCA footprinting because there's this regular ongoing monitoring for removals. What happens when there's a reversal? Like, what does that mean for the LCA I just did? And I think that's a really important point that like we just haven't figured out the perfect system to do this. There's a lot of work to figure this out, but this really doesn't need to be a barrier to entry. And I hope that, like organizations recognize companies for just, like you're saying, just taking, action that we can see is very impactful without needing to measure all of the things down to a carbon atom, right? So there is some promising developments related to this. So like SBTi just came out with that net zero V2 standard that I mentioned, and they talk about this concept of alignment targets, volume alignment targets. So that's saying, okay, like if you're sourcing volumes that are associated with good activities, maybe that's enough to demonstrate that you're aligned with a 1.5 degree scenario. And this is personally what I believe in. I think that, within agriculture, we should continue working on the greenhouse gas questions that we've covered today. But I think companies' targets should really just be focused to how many acres have you invested in and how many hectares have you invested in and how much change occurred on those. And is that in alignment with a 1.5 degree scenario? I think we can simplify this quite a bit for companies, and that would inject a lot more capital to farmers and to communities to create change.
Wow, what a great conversation. I think that's all of the questions we had from the audience, but also ending on a great call to action that, this work all has an endpoint, and that's trying to mitigate the harm that we do to our environment. So thank you both so much for your talk. And please, everyone, reach out to these lovely people if you have more questions.
Cool. Thanks.
Thank you, Noah. Thank you so
Okay.
much, Grant.
Oh, no, thank you. All right, see y'all.